Okay, I did a quick sound check and uploaded the last video to make sure that both the sound quality was okay and that I could upload it from my hotel room here. And everything looked good, so we'll continue. So what we're going to start with now is some UML. And remember that the focus this week is to give you the information and the tools that you need to do well on the homework assignment. We just did step one, which is the pseudocode. Now we're ready for step two, which is the UML. After the UML, that's basically all you need for the homework, but I'm going to continue with a live demonstration because many of these concepts are complicated, and we really have to see it work to understand what's going on. Okay, I'm going to start with the class diagram, and we remember, first of all, that we're in Argo UML. Argo UML is free, open source, and also written in Java. To find Argo UML, one second, let me resize my browser here so I can fit it in the window. To find Argo UML, go to argouml.tigris.org. You can either download and install it using the first link, or you can click to launch the latest stable release. That will launch it directly from your browser without the need for you to actually install an executable. Now, tool isn't what's important to me. You can use Argo UML or any other tool that you wish, as long as you get a UML diagram, a UML class diagram. That's what's important to me. So, given our pseudocode, we had some classes. We had a class called input income, a class called taxable income, and a class called dividend income. What we're going to look at now is the relationship among these classes. So I'm going to start with input income. I click on the box with the kind of the three compartments, and I click my cursor in there, and it gives me an option to give it a name. I'll say input income. In the middle box, I can put any attributes. We have exactly one attribute, and that is all income. It's actually not an integer type. Let me see if I can give it, if I can. Okay, good. In the old version of Argo, you couldn't make something up like I just did. I just changed that to an array type. You can also specify operations, or in other words, methods. So we have the main method, okay? And then I'm going to click on the box. I can either right-click and choose Add New Operation if I want to add another method, or I can select the box and then notice where my mouse is now, the new operation icon. The very bottom compartment is yellow. I can click on that as well. And for this I'll say prompt user. And finally we'll do one more. We'll call this one compute and output. I don't remember if that was exactly the name that we used, but it's fairly close. This is our user interface class. And remember, a very important part of good object-oriented design is keeping all the inputs and outputs, in other words, all the interactions with the user, separate from the data and the logic behind it. So this is our user interface class. Okay? Now, this class uses the income class. I think income tax we called it actually. That's what we call a uses a relationship, which is described with a solid line where my mouse is right now. And what's nice is UML knows this. So I can simply click this line and it draws a line in a brand new class. And this is what we'll call our income. Let me make sure I'm using the same vernacular here. Did we call that taxable income? Okay, this is what we'll call our taxable income class. Okay, and this had a few attributes, so I'm going to click on the new attribute and we'll say we had an income amount. We'll say double. See if it'll let us do, well, let's see, I'll switch it down here. Will it let me do double? Okay, well, I can just call it a double. How about that? And then we also had tax rate. Okay, and we'll call that a double as well. And then we had a method called compute taxes. Okay, there we have it. Now remember that income tax and tax rate will have getters and setters. We typically wouldn't need to represent those here. We could, but we don't need to. because it's pretty much a given. If we have an attribute, it's going to have getters and setters. So this is good. Remember, solid line indicates uses a relationship. Okay? Input income uses a taxable income. Also remember some of our concepts of object-oriented programming. We can have a class with some general terms, like taxable income. Then we can extend that class and give it more specific attributes and more specific behavior. We can extend it multiple times if we wish. For extension, what we need is another class that's related to taxable income, but with an up arrow. So I click on taxable income, and notice that if I mouse down a little bit, there's this arrow pointing up right underneath taxable income. I can click on that, and this is going to create a new class, and this is an is-a relationship. Okay, a little more on that. I'll tell you, let me fill in some details, and then I'll describe in more detail what an is-a relationship is. This we call dividend income, and this is a taxable income. A dividend income is a taxable income. It's just a more specific kind. That's why we call it an is-a relationship. Because in this dividend income, we can give it special attributes and special behavior. I click, okay, add an attribute. We'll call this qualified. And Argo defines a few types for us. Let me see if Boolean is already in here. There we go, Boolean. Okay. And now I'm going to give it a new method, and we're going to call this compute taxes. Very important. The compute taxes and dividend income has to look exactly like the compute taxes and taxable income, because we're going to give it a little more specific behavior in dividend income. So you see, as we get more specific, we can subclass a class and put specific behavior in there. That was a lot of words, so let me rephrase that. Taxable income is a general class that represents taxable income. Dividend income has a few specific concepts. It can inherit what taxable income already has, but then define a few special cases as well. We could do the same thing if we wanted with capital gains, which I'll do in a moment. Okay, there we have it. To be perfectly honest with you, at this point your homework's complete. Pseudocode, class diagram like this, and you're all set. But again, I'm going to continue to go with this example so that we can see this in demonstration. I can talk all I want, and you can replay and rehear it all you want, but a demonstration will really make it make sense. So just to show, though, taxable income, I can extend this again if I want for capital gains income. Okay. So we could say capital gains income. Okay, there's some special, and I won't actually do this one in the example, and we'll see if we have time. For this, we'll have a holding period, which would be an integer. Okay, and again, we'd have our own compute taxes method. I could also have something like foreign income. Income from foreign investments, which is taxed in a different way yet again. I could have a non-taxable income, in other words, income from government debt. Each of these is a special type of taxable income. Okay, I'll go ahead and drop a few on here. So we'll say non-taxable income. If you, a tricky thing, and I don't know why I bring this up in a programming class, but I will anyway. If you buy municipal bonds, in other words, you go to the state of Ohio and you lend them money, the state of Ohio will pay you interest. The federal government cannot tax that interest. So it's tax-free income. That's what we would call non-taxable income. I won't bother with attributes and methods on these. Well, I'll go ahead and put in the compute taxes method. Okay, again, this is more complex than yours needs to be. Yours will just have 3 classes on it. The interface class, the user interface rather, a superclass and a subclass. This is called a superclass. Each of these are called subclasses. You could also call this a parent class. Each of these a child class. You could also call this a base class. Each of these a derived class. You might hear these words, they all mean the same thing. Okay, I'll say compute taxes. And there we go. And then again, we could have one say foreign income. So we'll do one more. And we'll say foreign income is just weird. Okay. And for foreign income, typically there's a foreign tax withheld. You can use that as a credit against your U.S. taxes. And then once again, compute taxes. So there we go. That's our class diagram. Let me give you another example like this. I'm going to save this. Oh, by the way, when you do your program, let's see, my UC, okay, and we're going to call this inheritance class diagram. You can save it as a Zargo file, which you can open again and edit in Argo UML. Very nice. I usually do that. I will usually, after saving it like that, I will also export graphics and I will make it say a PNG or a GIF. That way I can take that image and just drop it straight into something like Microsoft Word. That'll be fine as a PNG. So we'll call this inheritance class diagram. There we go, like so. Okay, great. Another example. Let me just, to give you another example, we have something, like I mentioned, we have car. Okay. This is an example we see a lot in programming. Car will have something like miles per gallon is an integer. Okay. And then it might have gallons of gas. If this sounds familiar, you're probably in my Wednesday class because this is the example I usually use there. Okay, and then odometer. I would probably make gallons of gas a double here. Then we might have a method that we'll call move or travel. Let's call it travel. No, let's call it go. Int distance. Okay, good. Now, that's for a car. I'm going to extend this class into a Cavalier. Let's try a neon. Actually, let me click this, and there we go. Get my extension arrow here, and a neon. Now, I used to own a neon, a very not masculine teal neon, because it's all I could afford at the time. And a neon is a very basic car. So I declare this class neon that extends car. I don't need to say anything special here because a neon has miles per gallon, gallons of gas odometer, and it can move a distance. Doesn't really do much more than that. So it's just going to inherit everything from car. On the other hand, my father is a big fan of Prius. And so if we look at a Prius, that has all kinds of special cases. Okay, that might have things like a battery charge, and is it in hybrid mode or is it not in hybrid? So we'll say something like, we'll say electric on Boolean. Okay, then we might say battery charge, and that's for the battery that is actually running the Prius, not to be confused with the one that actually starts the engine. So that's something that a Prius will have that a neon will not have. Okay? And because of these considerations, we'll also want to give it a go method. Like so. Okay? So, neon, very basic car. Prius, a few more things to consider. Okay? Neon's fairly basic. Prius has a few more things to consider. We could also have Cavalier, which is somewhere between a neon and a Prius. Cavalier, or as the younger generation would call it, a Cobalt. I'm old school, so I'll say Cavalier. Okay, Cavalier had a few options that the neon did not have. For example, you could get a convertible. So we'll put that as a Boolean. Is it a convertible? And then we'll say, okay, is it a Z24? It was the bigger engine Cavalier. Okay, now here's what's interesting. Can you get a neon convertible? No, you can't. Can you get a neon Z24? No, you can't. So these attributes are specific to Cavalier. They're not in neon, and they're not in car. They're specific to Cavalier. In a Prius, can you get a convertible Prius? Not that I know of. Can you get a Z24 Prius? Not that I know of. So it makes the most sense to put these attributes here in Cavalier, not in neon, not in Prius, and not in the supertype car, because the superclass should only have the attributes that are true for all subclasses. So there we have it. Okay, given this, I'm going to open up NetBeans, and I just installed this NetBeans on this laptop, so hopefully everything's in good and operable condition. And again, just to kind of remove the minutia of everything else we've done, I'm going to start fresh on this example. So I'm going to go to, this is a bit off screen, I'm trying to maximize the screen space here. File, new project, Java application. We'll call this project name Tax Computer. Now again, you don't have to do this for your program, I just want to show a live demo. TaxComputer.InputIncome will be our main class because that will be our user interaction class. And finish. We'll give it a second here. Okay, there we go. And I will, again, I'm maximizing screen space here. We have our main method. Now I also said in pseudocode I was going to make a prompt user and a compute taxes method. So public static void prompt user. Okay, open and close curly. And then we'll say public static void compute and output, I think is what I've been calling it. Something like that. We get the idea. Okay, I also said I'm going to need an array. I'm going to take some liberties here. Since I've already shown you everything you need for the homework, we know also that you're not responsible for the syntax of the Java programming language in this class. I'm going to use a special collection called an array list. I don't expect you to know what this is, but it's something that will make my life a bit easier. Actually, I can't use that yet anyway, so hold that thought. We'll come back to that. Okay, the main method we said in our pseudocode would call prompt user. Okay, and then after that it would call, compute and output. Output. Compute and output. What did I misspell? Missing a T. There we go. Okay, so is this true to our pseudocode? Just make sure we're, invoke prompt user, compute and display. Okay, well, that's fine. We can call it either one. We get the idea. I'll change that to compute and output because I think I put it in the UML as compute and output. Okay, there we go. Easy enough. Okay, so we have our prompt user method. We're going to have to say more income to enter. Okay, and then we'll have a while loop and then an if test. Believe it or not, this one won't be too bad. Okay, prompt user. I'll say string income to enter equals JOption pane, show input dialog. Do you have income to enter? Okay. Now I need to organize imports because it doesn't recognize JOption pane. Okay, so we have that. Now, I'll say while income to enter dot equals ignore case yes. Just say basically as long as there is income to enter. Okay, and we keep going. Okay, now we're going to say string income amount equals JOption pane dot show input dialog. What is the amount of income? Okay, and then we'll say double DBL income amount equals double dot parse double income amount. So just convert it to a number. I'll put that here. I'll put a comment to that effect. Prompt for income and convert it to a number. Okay, now is this dividend income? Okay, string dividend income equals JOption pane, show input dialog. Is this dividend income? Okay, now if dividend income equals ignore case yes. Okay, put a comment. If we're here, we have dividend income. Else, if we are here, we do not have dividend income. Okay, take a look at that for a moment. Okay, now, if I compare that to my pseudocode, make sure I'm on the right track. How much income is this dividend income? That looks good. I need to handle the taxable income and the dividend income classes now. Remember, what's a good programming practice is to have a large number of small classes that do very specific things. A large number of small classes that do very specific things. What we don't want are classes that try to do too much, because they get big and they get very hard to manage. This class should purely be doing user interface logic. In other words, this should only be interacting with the user. That's all. So we're going to make another class called Taxable Income. Okay, I'm going to save. And I have no red lines now, so it looks like I'm in good shape. Okay, I'm going to save. I'm going to resize this. Under Tax Computer, I'm going to right-click and choose New Java Class, Taxable Income, and finish. Okay, taxable income. What was I going to declare there? If I go back to my pseudocode. Okay, income amount and tax rate. Okay, that's good. Income amount and tax rate. Okay, that'll work. So I'm going to say private double income amount, private double tax rate. Okay, now we'll create getters and setters for this. So I right click and choose refactor and choose encapsulate fields, check all the boxes, and then choose refactor. Okay. For tax rate, okay, let's see, I'm sorry, there was one other method I need too. I need a method compute tax, which is going to return a number which represents the income amount times the tax rate. Okay, so I can put that anywhere as long as I'm within the class and not within another method. So public double compute tax. Okay, income amount, oh, let's say, I'm sorry, tax owed equals income amount times tax rate. Okay, return tax owed. So because I have, I'm sorry, make that a double. Because I have here a method with a return type, the method needs to do some computation and then return a value of that type. So this method compute tax is going to do a computation and return the tax owed. And there we go, and I save. Okay, now back to input income. Okay, what I'm going to do here, I'm going to handle the else part. We'll do the else part first. In the else part, I'm going to create an object of the taxable income type stored in a variable. Let me expand this so we can see the full screen. Named TI. Okay, taxable income TI equals new taxable income. Notice that we have a variable here named TI, and the type of variable is a type taxable income. Okay, now we'll say store the income amount in TI. TI.set income amount. And remember, up above, take a look, NetBeans has figured it out for me. Up above, we declared a local variable named income amount, and right now we're passing that into set income amount. And there we go. And save. Okay. Now, we are going to be able to handle multiple types of income, or multiple pieces of income. So now what we need to do is add this to an array. An array or a collection of different taxable incomes. This is where I can go back to where I was going to cheat before. I need to declare an array. I need to declare an array that will hold all of my taxable income objects. So I'm going to scroll to the top and we're going to make it an attribute. I'm going to say an array to hold all taxable income units. Okay, array list. Again, I'm not holding you for Java syntax, so I'm going to take some liberties here and use something that's a bit more convenient in this situation, which is an array list. Array list taxable income, all taxes, all taxable income, let's call it that, equals new array list taxable income, boom. Static. Make it private static. Okay. It doesn't know what array list is, so I have to import it. And again, I'm taking a little shortcut here. I wouldn't hold you responsible for this. Okay, what I can do now is go back to the else part, and I can add this taxable income item to the array list. So I'll say all taxable income dot add, boom, TI, there we go. That way, if the user enters, say, 5 different taxable incomes, I can hold them all in one variable. If the user enters 1, I hold them all in one variable. If the user enters 250, I hold them all in one variable. So that starts our process. At this point, we're at the 27-minute mark again, so I'm going to pause and save this presentation, and then I'm going to start a new one. Again, I do it in about 30-minute increments. First of all, these are about 200 megabytes apiece, and I don't want to overload anybody downloading them. Secondly, in case I mess up badly, if I only do 30 minutes at a time, that's the most I have at risk. So I'm going to pause this, and when we pick back up, we're going to take a look at dividend income. Okay, see you in a few.